Alright, I guess this is episode 3, balancing algebraic equations. And I'm going to talk about kind of the game we played on Friday with the Dragon Box and what that has to do with algebra and what that has to do with math. Alright guys, the first problem we're going to work out is this problem right here that you see on this website, x plus 6 equals 2. So a way to think about this in your notes is to write this out. You kind of have a question box, kind of like in looking for a number. What number plus 6 equals 2? So one strategy a lot of kids use is just kind of guess and check. I heard somebody, what number do you guys think it is?
-4.
Give me a wrong answer.
-3.
Like maybe the answer is 3. Okay, well let's check that. Is 3 plus 6 equal 2? No. What if the answer was 4? Is 4 plus 6 equal 2? No. So the answer has to be a what kind of a number, guys? A negative number. And what kind of negative number do you think it is?
-4.
-4, right? So -4 plus 6 equals 2. Alright, so instead of guessing, I'm going to show you guys a strategy. How can you work out these problems without guessing through all of the, without guessing a bunch of numbers? Okay? So one strategy uses this little balance scale. So everybody look up here. And you think about the Dragon Box game that we played on Friday. The Dragon Box is this big X. You'll see that? So right here is X. That's kind of the Dragon Box that we did on Friday. And this says X plus 6. So these are positive. So 1, 2, 3, 4, 5. But we can't click 5. And try to get 6. So this says X plus 6 equals 2 of these positives. So we got to figure out how can we get that X by itself. Remember playing the Dragon Box game? What was the point of the game? What was to do what with the Dragon Box? What was the point of the game, guys? Who remembers? Andrew, what was the point of the game on playing on the Dragon Box? The point of the game was to do what? To get the box by itself, right? And how we did that, you remember playing the game? How did we make the box by itself? We had to do the what of the picture they gave you. Like if they gave you a red picture, you had to match it with a what?
Opposite.
With the opposite, with like a blue picture, right? So it's the same thing here. That's what you did the game here. What is the opposite, everybody, of a +1?
-1.
A -1. So you put the -1 on one side, you put the -1 on the other side. Remember that in Dragon Box, they made you do it one side to the other side? So it's the same thing here. What happens when you have a positive and a negative, everybody? Everyone should know this. A positive and negative make what? Yeah, what kind of pair is it called? What number?
+1 and -1?
Alright, so when I have a positive and a negative, I make a what, everybody?
A zero pair.
A zero pair. And if I put one negative on this side, I have to put one negative on the other side, just like in Dragon Box. So these make 0, these make 0. I'm going to make this make 0. I'm going to make this make 0. I'm going to make this make 0. Put negative over here. So negative over here, and negative over here, and negative over here. Whoops, and a negative over here. So what I'm left with is all of these will go away. Do I have any 0 pairs on the right side?
Yeah.
Yes, I do. I have a plus and a minus here. So let me take these away. I have a plus and a negative. Take these away. And what am I left with on the other side?
-4.
-4. And that's what we said our answer is. I'm going to take away all my 0 pairs. So I take away all my 0 pairs. And what I'll be left with is one Dragon Box, one X equals -4. So that's the strategy that we're going to use here to solve these problems. So go back to your notes and you finish it out here. So 1x equals -4. Oh, sorry, I have a +1 hanging out here. 1x equals -4. So let's go back to our notes. Now we're going to draw that out what we just did. So kind of like draw, like in Dragon Box, draw the same thing on your paper. Okay? We had two sides. We had two sides, the left side and right side. What side did we mostly care about it in the game? The side with the what? With the box, right? You cared about the side with the box. So that's going to be, I'm going to draw a little question box. +6. This means 6 positives. Remember how to draw a positive. Plus sign. 1, 2, 3, 4, 5, and 6 over here. Equals 2 positives. Okay? So just like in the Dragon Box, how do I get rid of the opposite of a positive? I have to draw a... How do you get, what's the opposite of positive?
Negative.
Negative. So I got to draw a negative over here. And if I draw a negative over here, I need to draw it over here on the other side. Okay, remember that. Whatever you do to one side, you have to do to the other side. So we're going to keep on doing that to make 0 pairs. And don't forget, if I draw a negative over here, I've got to draw a negative over here. It's just like how it worked in the Dragon Box game. If you haven't played the Dragon Box game yet, and you're watching the video, we're going to try to do it again this week. Hopefully it'll make more sense. So remember to cross out your 0 pairs. So those cross out, those go away, those go away, those go away. And we're left with what? The x equals, what do I have left on this side? I have 4 negatives left. So x equals -4. Okay? And that's how this works. So the biggest thing to remember is we use this phrase in algebra, and it's called isolate the variable. What does the word isolate? Anybody know what the word isolate means? It's a big vocabulary word. Isolate means to make by itself. So what this means is you want to make, and then the variable is this, the x. The variable stands for the x. It can be any letter. Sometimes you guys look on IXL and sometimes it's the letter C, or it's the letter Q, or it's the letter R. The variable is the letter in the problem. That is the variable. So to isolate the variable, you need to, what that means is you need to make the variable by itself by creating 0 pairs. Okay? So you need to make the variable by itself by creating 0 pairs. You want to do the opposite of things. Okay, that's all the notes I'm going to give for this. We're going to practice doing this in class tomorrow, and we'll go back to playing the Dragon Box game at some point this week to kind of, you can see what that has to do with math. And that's our example for today. So copy the notes down. There is no risk. There's no summary. Just bring the notes right to class tomorrow.